Okay, so welcome, ladies and gentlemen. Our review is going to last a couple hours. I'm going to do a lot of pausing on the video so that I don't have to record for 2 hours. Polynomials and recursion are the two major topics we're going to cover here. This one and this one. We will have a few random topics thrown in there too, just to kind of talk about the whole big test as a whole. But first of all, in polynomials, on that packet that you were assigned yesterday, there might have been a few that really stumped you. I was intending that the sub tell you that these were problems that you did not have to know how to do. 8, 9, 10, 13, and 20. At least write them down on your notes here as ones that you don't have to worry about on your polynomials packet. 8, 9, 10, 13, and 20. Your assignment is, I'm sorry about that. I know that I specifically emailed one of my colleagues and they said, yeah, I already told him about it, so I figured he was going to tell you, but anyway, just didn't get there, obviously. So you were only assigned through 16. Your assignment now is to do the rest of the polynomials packet, which is 17, 18, 19, 20, and like 21 or 22 or something like that. Anyway, the rest of that packet, and number 20 is in there, skip it too, okay? All right. Polynomials isn't just about graphs that have like lots of curves and minimums and maximums and increasing and decreasing and ends going up and ends going down end behavior. A lot of it's about factoring using rational root or synthetic or long division so that they look kind of like this. You'll have a factoring problem like this. It'll say use the rational root theorem, maybe even give you that hint to factor it. Rational root was the one that was fcon over fco. Do you remember that? Factors of the constant over factors of the coefficient. All right. Which of these is the constant? That's the constant. And what's the coefficient? It's the lead coefficient is the one we're talking about. It's 1. Good. So then if you're going to figure out whether or not this has possible roots, you're going to get a list of all of those roots by doing the factors of the constant over the factors of the coefficient. Factors of the constant are 1 and 12, 2 and 6, 3 and 4. Any other way to make a 12 I'm not thinking of? All right. Over the factors of the coefficient, which is just 1. And you got to remember to do plus and minus of all of those. So there's a lot of possibilities. 1 could be a factor. 12 could be a factor. 2 could be a factor. 6, 3, or 4. And notice dividing by 1 meant I really didn't have to do anything to that. So those are all my possible factors. I'd like you to just check right now and see if 2 works. Go ahead and check 2 and see if 2 works. Now, how would you check it? Factor it. Well, you can try to factor it the hard way or you can use synthetic. So what I'm really asking you to do here is take the 2 and check and see whether, with synthetic, whether the 2 goes into it or not. Okay. Yep, and from here we've written out our synthetic and we're just going to go 1 times the 2 makes 2, and then I add them and that makes 5, and then I multiply them and that makes 10, and then I add them and that makes 6, and then I multiply them. 6 times 2 makes 12, and then I add them and I get 0, and that means it worked. There was no remainder. Okay, now this is just some dumb process if you don't know what we're doing. What we're doing is finding the factors, like what times what makes all of this. And what works is that 2 means x minus 2. Remember this? And then this part is the other part. That's this part. So translate that for me. Who can do it? Yes. 1x squared plus 5x's plus 6. These are the x squareds, these are the x's, and then these are the plain old constants. Okay? All right. So then, common mistake is for kids to factor it to that and say, I'm done. What's wrong with that? You can factor it farther. So we go x minus 2, and then this breaks into 2 sets of parentheses. Factor it farther. Everybody. Okay, so I start with an x and an x, and then what should I do? It has to multiply to 6 and add to 5. Very good. So you explained that very well. All right, good. So that means I've got 3 roots. Remember this? What's the root for this one? 2. What's the root for this one? Negative 2. And what's the root for that one? And the roots are the same as the zeros. Probably would have been better to say zeros in this case because this number makes this little part 0. The idea? All right, so I have 3 roots, and this had a 3 here. Remember that deal? If there's a 3 there, there's supposed to be 3 roots. What if I had only come up with 1 root? But I know there's supposed to be 3 roots. The other 2 must be imaginary. All right. All right, moving on. This is long division. Same idea, it's just harder because you're not as used to long division. Since the final has, it could have long division on it, but there are times when you cannot use synthetic because they're going to want you to check, for instance, if x squared plus 2x plus 3 goes into x to the 4th plus 5x squared plus 7 or something like that. That you can't test with synthetic, can you? So there are times you have to do long. So I'd like you to try this one. It's a simpler one with long division. See if you can handle it all by yourself. I'll get you started in a minute in case you're having trouble. So to test this thing, I first have to set up something on the top that will multiply with this to make the first term work. It's only the first term that has to work. So how many of you guys knew to start with x squared? Good. Okay. Then if you use x squared up there, you times it by both parts. Times that, and then times that, and that's x to the 3rd, and then it's plus 3x squared. Then you got to change to opposite of both. You remember that? And then that cancels both of them, and there's 0 and 0, and so then you got to bring down some stuff. In fact, if there's 2 terms here, you got to bring down 2 terms. Negative 4x minus 12 all at once. And then again, it's the first term you have to match up. So I got to put something here so that I can go times x and make negative 4x, and that's a negative 4. Negative 4 times x makes negative 4x, and negative 4 times positive 3 makes negative 12. Change the signs, and then they'll cancel, and I get 0 and 0. So it's a remainder of 0, which means did it work? Yes, it worked. And what was the answer? The answer was the whole thing. X plus 3 and x squared minus 4. But if you left it like that, you're wrong. How many of you remembered that? Good. Okay. X plus 3 and then x minus 2, x plus 2. Okay. It has 3 roots. Am I expecting 3 roots from this thing? Yes. All right. Moving on. Long division again. The only thing I wanted to remind you about here, and we won't even bother to do it, is placeholder. If you need a placeholder, you got to hold the place with a 0. And so if I was going to do this for synthetic, first of all, do you know what to put in here? You don't put x plus 4 if you're doing synthetic. Negative 4. It's the root of this factor, the thing that would make that 0. Okay, that goes in there. And then for as far as placeholders go, if I just go 1, 2, 5, that's where I'm going to get it wrong. It will not work. You see where I should have the placeholder between the what and the what? Between the 1 and the 2. Because right in here, there should be an x squared. There's 0 x squareds in there, so there should be a 0 right there. All right? Okay, moving on. Polynomials. When it comes to the graphs, we know a lot of stuff. There are so many things in this topic. All right, I'm going to fly through a bunch of them. Since the degree can be told by the fact that the ends go opposite directions, that's either odd or it's even. Do you remember? Since you're going opposite directions, what is that? That's odd. So I know it's going to be odd. Now, this might not even be the right answer for that. So don't perseverate on the fact that it's sitting there. We have to judge based on what we know. I know it's odd, and I also know that since on the right-hand side it's going up here, that means what about my equation? It has to be positive at the beginning. And one of the way they might say that is the scale factor is positive. What's the scale factor if this was the equation? What's my scale factor here? 1. And so there's a 1, and that's a positive number. So my scale factor would have to be positive because it's going up on the right. Next thing is increasing and decreasing. Basically there you just have to know that from here to here it's doing what? Going up, which is called increasing. And then from here to here it's doing what? Decreasing. And then from here to infinity it's doing what? It's increasing from 4 to infinity. All right. And let's see. We'll talk more about the next things on the next video.